More strategies for finding common denominators. We are on lesson 2 of unit 5. In this lesson, we're going to be able to practice strategies for finding common denominators, using common denominators to add and subtract fractions. We're also going to be able to use equivalent fractions as a strategy to add and subtract fractions. Let's take a look at some words that we need to review before we get started. First up, common denominator. Remember that for two or more fractions, a number that is a multiple of both or all denominators, for example, the fractions 1/2 and 2/3, they can have a common denominator of 6, 12, 18, and so on. If the fractions have the same denominator, that denominator is called a common denominator. Factor, whenever two or more numbers are multiplied to give a product, each of the numbers that is multiplied is called a factor. For example, in 4 times 1/2 equals 6, 6 is the product, and 4 and 1/2, or 1 5/10, are called factors. So we can compare factor of a number, of a counting number, in when you're looking at definitions. Factor pair is our next set of vocabulary. That is two factors of a counting number whose product is that number. A number may have more than one factor pair. For example, factor pairs for 18 are 1 and 18, 2 and 9, and 3 and 6. This means that 1 times 18 equals 18, 2 times 9 equals 18, and 3 times 6 equals 18. We have multiple of a number n, which is the product of n and a counting number. For example, the multiples of 7 are 7, 14, 21, 28. We go into 35, 42, and so on. Quick common denominators, or a QCD, as you can see in the parentheses there. That's the product of the denominators of two or more fractions. For example, the common denominator of 1/4 and 3/6 is 4 times 6, or 24. As the name suggests, it is the quick way to get a common denominator for a collection of fractions, but it does not necessarily give you the least common denominator. It is just simply the quickest, taking the denominator times the denominator to give us, excuse me, the QCD, quickest common denominator. So here we have our math message. Now, if you are virtual and you do not have someone near you that you can do this with, don't worry, we are going to have a little discussion for you to respond to this. So our math message is, you read the multiples student reference book on page 72, and you can look at that on the Everyday Math website and in your ebooks. List the first 6 multiples of the number 8. The other person is going to read about factors on SRB page 73 and list all the factors of 36. Then you're going to tell your partner what you learned and shared with your list. So we will look forward to an online version of this discussion so that you can talk about what you have read about on page 72 and page 73. So look forward to that. Some more information about factors and multiples. You can see here, a number is a factor. You can see that word in bold here, of another number if it divides the other number evenly. There's no remainders. So you have to ask yourself, what are the factors of 36? So what numbers will divide 36 evenly? I know 1 and 36 will. And we can look at the 6 is an even number, so we might ask ourselves, can 2 go into 36 evenly? And if the answer is yes, then it is a factor. Can 3 go in evenly? And so on. We often refer to factors as a part of a factor pair, or two factors that have the number as the product. For example, 4 and 9 are factor pair of 36 because when you multiply 4 and 9, you get the product of 36. So you want to ask yourself, well, what are the other factor pairs of 36? And a multiple of a number is the product of that number and another counting number. Because numbers are infinite, there are an infinite number of multiples for each number. So we might often see what are the first 6 multiples of 8. So for this, you'd be saying 8 times 1, 8 times 2, 8 times 3, and so on. Why is it impossible to list all the multiples of a number? Our answer is right here in this definition. Because numbers are infinite, there is an infinite possibility because we can do 8 times a million, 8 times 2 million, and so on. We can keep going on and on. Multiples are never ending where factors have a set amount. So you can see here, we listed the factors and the multiples for 12, 20, and 29. And you can see some differences here. We've got factors. We know we've got 1, 2, 3, 4, 6, and 12. All of those are factors of 12. We know we can do, I'm going to use my pen here to demonstrate. We can do 1 times 12, 2 times 6, and 3 times 4. Those equal 12. Notice we don't repeat. Once we get to 4, we've already said 3. Once we get to 6, we've already said 2. Once we say 12, we've already said 1. Now with the multiples, you can see that they listed the first 4 of 12. They did 12, 24, 36, 48. This would be like saying 12 times 1, 12 times 2, 12 times 3, 12 times 4. We could go on and do a 12 times 5. We could continue forever listing the multiples of 12. For 20 with the factors, change my pen color here, we can see that we did 1 times 20, 2 times 10, and 4 times 5. And then they did 1, 2, 3, 4, 5. They did the first 5 multiples. We know the next one would be 120, 140, 160, 180, then 200. We would keep going up 20s. And finally for 29, see these are ones that we're used to. 29 is an odd number. Take a look at that. It only has 1 and 29. Nothing else can go into it evenly. So the only factor pairs for 29 is 1 and 29, 1 times 29. But the multiples can keep going on forever. We can see this is 29 times 1, 29 times 2, 29 times 3. So they did the first 3 multiples of 29. So we have 2/3 and 5/9 here. It's asking us to list several equivalent fractions for each addend. So we have 2/3, we would want to create equivalent fractions for them. And we have 5/9, and we would want to create equivalent fractions for that. So what I want you to do is to pause the video and create some equivalent fractions and ask yourself, what fractions do you see have the same denominator? So create equivalent fractions for 2/3, create equivalent fractions for 5/9, and see if there's any that have the same denominator. And what do you notice about the starting denominators, 3 and 9? And then the common denominator of 9. So we're kind of giving you a hint. They do have a common denominator of 9 here. The common denominator 9 is the same as one of the original denominators. 9 is a multiple of both the original denominator, 3 and 9. 3 is a factor of 9. So one strategy for finding a common denominator of 2 fractions is to see if one denominator is a multiple of the other. We can go back to this and take a look. You can see that 3 can become 9. So when we're doing this, I can create 2/3 equals something over 9. And I know that I can take 3 times 3 to get 9. So I'm going to do that same thing to the top. I'm going to do 2 times 3. And I know that I get 6/9. So now I don't have to do anything to this one. I can simply now take 6/9 plus 5/9. I can add now. My denominator, remember, will stay the same, so that's going to stay as a 9. And then I'm going to simply add across. I've got 11/9. It's an improper fraction, but that's what that equals. So if it is a multiple of the other number, that the denominator can be used as a common denominator. So we've created the common denominator of 9. Once you found that common denominator for 2 fractions, you should use multiplication rule to generate equivalent fractions, and that is what I did over here in this area, and I created that common denominator. Whoops. Then we can move on and add those. So you can also use the multiplication rule to find a fraction equivalent to 2/3 with the denominator of 9. And that I don't really understand what this slide is asking because we just did that. So let's skip that one. It's okay. What if we did a subtraction problem? Can we do 2/3 minus 5/9? Taking a look at my work in green, I'm going to switch to blue for this one now because now we're going to do a subtraction problem. I've already done my work over here of creating an equivalent fraction with a denominator of 9. So I have the common denominator. So I'm just going to rewrite this as a subtraction problem, 6/9 minus 5/9. And this time we're left with 1/9. So you'll see that it still works. It works for either addition or subtraction. We still need to have that common denominator. And that should be review for you because I know that that's something similar to what you've learned in 4th grade and we've talked about throughout 5th grade. So another strategy for finding a common denominator is to multiply the two starting denominators. And that is called, as we talked about earlier, quick common denominators. So if we had 2/3 and we'll just do plus 1/9, I'm going to do that. A quick common denominator would be to simply multiply these two. So find the quickest way is to take a 3 times 9. And so we know that the common denominator would be 27. So now you're going to take 2/3 equals something over 27. And we know that we took 3 times 9. And so we're going to take 2 times 9. And that gives us an equivalent fraction of 18/27. And then the same thing for 1/9. I'm going to make 1/9 equal to something over 27. Well, we know that we took 9 times 3, so 1 times 3. So now I've created, that should be a 7. Now I've created two fractions, two equivalent fractions that have common denominators. So I'm going to take 18/27 plus 3/27, and I can add these. I can do that 18, 19, 20, 21. So now we have 21 over 27. That's not the least common denominator, but it is the quickest common denominator. Or a quick, maybe not the quickest. So here's a quick common denominator for some we can do. We won't solve the whole, there's no addition or subtraction, but let's just find the quickest common denominator for these by doing the multiplying. So 3/7 and 7/8, we want to take 7 times 8. 1/4 and 2/3, we would take 4 times 3. And then 1/10 and 3/5, we would take 10 times 5. So we know we would get 56, 12, and 50. So I want you to think about this, the strategy of the quick common denominator. How does that strategy work? And what do you have to do? Think about that. What kind of math do you do with when you're doing the quick common denominator? So while the quick common denominator, QCD, always works as a common denominator, it will always be there. It may not be the smallest denominator that you find when you're listing your equivalent fractions, though. If the product of the denominator results in a large number, you may want to try one of the other strategies for finding a common denominator to see whether There's a smaller common denominator available. They don't always work to be the best, but it always works. So turn to page 156, 157. At the top, I want you to take a moment and summarize the strategies for finding common denominators. And then put a star next to the strategy that you personally prefer. So you can look back through this video. You can look back on in your math journal. You can look at the Everyday Math website for common denominator strategies, and then pause the video, fill this out, and star your favorite. All right, now it is time to do some practice on page 156. So you're going to use any of the strategies that you talked about. Probably you're going to use your favorite one, and that is fine. You're going to rewrite each of the fractions using a common denominator and then solve the problems. Number 1A has an example there for you. They have 2/9 and 5/6. The common denominator for those two would be 18 because you can take 9 times 2 and you can take 6 times 3. So here you see they turned 2/9 into 4/18, and they took 5/6 into 15/18. That bingo game that we played on the last flex day would be a perfect way to practice if you're still struggling with finding common denominators. So now you're going to take this information and you're going to plug it in. You're going to now add, subtract, and then figure out which one is, if it's larger, less than, or equal. Number 2, same thing, except you're going to be working with 3/4 and 7/12. Tell me what a common denominator is. Tell me what these are as equivalent fractions with common denominators. Add them, subtract them, and then greater than, less than, or equal to. And number 3, 4/7 and 1/2. Adding, subtracting, greater than, less than, or equal to. Pause, do those 3, and come back and check. So for number 1, you should see that the answer is 19/18 or equivalent, or you could say 1 and 1/18. C is 11/18, and D, 2/9 is less than 5/6. You can pause the video and read this explanation for part 1 if you would like to. Number 2, when we're looking at 3/4 and 7/12, has been very touchy today, so there we go. The common denominator is 12. The equivalent fraction for 3/4 is 9/12. 7/12 equals 7/12. You see that we did not change that one. It stayed the same. You don't have to change it if it doesn't need to. Don't do more work that is than necessary. B, if we add the two fractions, we get 16/12 or 1 and 4/12. You could even have something different if you went even further. You could have 1 and 1/3. C, if we subtract them, we can have 2/12, or you could reduce it even more and have 1/6. And we know that 3/4 is greater than 7/12. Again, explanation for problem 2 at the bottom. Pause if you'd like to read. And 3, 4/7 and 1/2. Let's take a look at that common denominator. The common denominator is 14. So 4/7 equals 8/14. 1/2 equals 7/14. So if we add them together, we get 15/14, or 1 and 1/14. If we subtract them, we get 1/14, and we know that 4/7 is greater than 1/2. Once more, problem 3 explanation just below. On page 157, we have a few more problems for you to do for some practice. For each problem, find a common denominator and write which strategy you use. Then write the fractions using a common denominator. So are you doing the multiplication strategy? Are you listing the multiples? Are you doing quick common denominator? which strategy do you choose to do? Again, it's up to you. So listing the equivalent fractions, noticing the denominator, quick common. Number 4 is 2/3 and 10/15. 5 is 1/4 and 2/9. 6 is 5/6 and 3/4. And 7, you're to answer, what other strategy could you use to find the common denominator in 6? And which strategy do you think is best and why? So pause your video now and work out the strategies, the common denominators, adding or subtracting, and then come back and check your work. Number 4, the strategy that they used was noticing that 15 was a multiple of 3, so they only changed 1. They got 10/15 and 10/15, so that's 20/15, or 1 and 5/15, or 1 and 1/3, and 2/3 equals 10/15. Number 5, they found a quick common denominator. You could have done something different, and they've got 9/36 and 8/36, so they changed the denominator to 36, and so when they subtracted it, they got 1/36, because this one was a subtraction problem, and they found that 1/4 is greater than 2/9. Number 6, they listed the equivalent fractions. You could have done quick, you could have done multiples, but what they did was they created 12 as the common denominator. They got 10/12 and 9/12, so they added them, and they got 19/12, or 1 and 7/12, and then when they subtracted, they got 1/12. Now, C7 is going to be some sample answers because it's what you're feeling, but the strategy that you could have used would be to multiply 6 and 4 to get a quick common denominator. You could have done that. Now, that wouldn't have been the best one. The best one is listing the equivalent fractions because it gives a smaller common denominator, 12. So even if you had 24, so say that you did 24 as the common denominator, it would have worked, but it's not the best one. So in this lesson, we just did more strategies for finding common denominators. Hopefully some of this was review for you. If you feel like you're struggling, don't forget you can check out Khan Academy for common denominator and equivalent fraction videos. Don't forget to check out your assignment to find out what other tasks you need to do for today.